Alright, hi you guys. Today we'll be talking about the significance test. And the significance test is to tell whether or not someone is telling you a lie or a truth with statistics. For example, like one of the most famous ones is you'll find as a college student is how come my bag of chips has so little amount of chips in it and stuff. And so what you can do is you can actually use the significance test to tell if the company is actually telling the truth or if they're telling a lie and it actually backs it up. So here's the three stages. Okay, first off, you write your null hypothesis. So you state your null hypothesis, and then what you're going to do is state your alternative hypothesis, and we'll talk about that in a sec before we actually start on the problem. And then what we'll do is we'll start working on some calculations, find the z-score, and the z-score is going to be a little bit tricky, so please follow along. And then what we're going to do is we're going to find the p-value using our calculators. And then you can arrive to your conclusions. So your statistical conclusion and your contextual conclusion are the next step. Okay. All right. So first off, the null hypothesis. Now the null hypothesis is going to be kind of using the jury method or the method of the United States of America justice system, which is assume innocence until proven guilty. So your null hypothesis is always going to assume innocence, so it's always going to back up whatever they claim. Okay, and then your alternative hypothesis is what you're going to accept if they are guilty. Okay, now on the z-score, okay, z-score, okay, your z-score is going to be x bar minus whatever your mu is. Let me see if there we go, I draw out a mu. They're great. Okay, and it's going to be divided by, well, yeah, your s. Now your s is going to be basically, your s is going to be equal to the sigma divided by the square root of the sample space. Okay. All right, so as long as you're used to that, you should be good. And then p-value, we'll talk more about that in a sec, okay? All right, without further ado, let's go try a problem. All right, so Bon Air Elementary School has 1,000 students. The principal of the school thinks that the average IQ of the students at Bon Air is at least 110. To prove her point, she administers an IQ test to 20 randomly selected students. Among the sampled students, the average IQ is 108 with a standard deviation of 10. Based on these results, should the principal accept or reject her original hypothesis and assume a significance level of 0.01? Assume that the test scores in the population of students are normally distributed. Okay, so what we're going to do is we're going to state our null hypothesis and alternative hypothesis first. Okay, so our null hypothesis is going to be if our mu is greater than or equal to 110. Okay, so we're assuming that the principal is telling the truth, that her average test scores is at least 110. Now, our alternative hypothesis is going to state that these scores are less than 110. But remember, we're going to assume this one's true until we prove it false. So we want to have this one be true. Okay, maybe I shouldn't use an exclamation point. That looks like a factorial. I want this one to be true until I prove it initially false. Okay, so now what we're going to do is we're going to do some calculations. All right, so I calculate S, and it's going to be the standard deviation 10 divided by the square root of 20, which is 2.24. Okay, so when I go to calculate my z-score, it's going to be about negative 0.89. Okay, that's going to be my z-score. So this is going to give me what the actual amount is. Okay, all right, now I go to calculate my p-value. Now what I'm going to do is put that in my calculator, normal CDF. Okay, now with the lower end, we're going to want it to be at negative 10, and the upper end, we're going to want it at negative 0.89. Okay. So just remember to calculate that real fast. Now the lower end bound is obviously the t-tables or the the p-value tables, they don't go lower than -3.59 because then we're talking about something that's so far from average that we don't even consider it. So -10 and lower, I mean, you could literally put a -99. It's totally up to you. But I'm just going to use -10 just for the sake being. Okay? All right. And you do that calculation and you should get 0.187, I would say. Okay. And now what we're going to do is we're going to compare that with what we have. Okay. Now what we're going to do is we are going to compare this 0.187, and we're going to compare it with our significance level, which is 0.01. Okay, and obviously this one's going to be greater. Okay, so what that means is that means we would expect to find a sample mean of 108 or smaller in 19 or 18.7% of our samples if the true population IQ were 110. Okay, this is greater. So since it's greater, we cannot reject the null hypothesis. So what that means is we cannot say anything about guilty. We don't say anything about alternative. We just kind of forget about it. And we just say you cannot reject the null hypothesis. Okay, and here's how it's going to look. Okay. All right, we cannot reject the null hypothesis since our p-value is greater than the significance level. Okay. Now, we would also use that in context of the problem. So what we could do is, based upon these results, should the principal accept or reject her original hypothesis? The principal should accept. The principal should accept the original hypothesis. Okay. Now I do want to point out one thing. A significance level of 0.01 is the same as a confidence interval of 99%. So you can quickly go between the two numbers just so you know what you're comparing it with, okay? All right, and normally this one, if it goes without saying, this is normally about the 0.05, but in this case it was just 0.01. Okay? Now, what can we say about this problem? It is done very well. Well, no, it's not done very well. It's done by a human, so sometimes that happens. I do want to go back to one thing real fast and just cover what the null hypothesis and the alternative hypothesis is going to look like in each situation. All right, so here's the situation. For your null hypothesis, here's how you can line them up with the alternative. Okay, so the null hypothesis, if you want the null hypothesis or the mu to equal a certain number, the alternative is it doesn't equal a number. Okay, and the tail test you would do is a two-tail test. Okay, now in our case, the problem we just did was we assumed that the mu was going to be bigger than 110. Okay, and what we found was that the alternative was going to be less than 110. Okay, and that's why we did the one tail test and the one tail test for if it's less than or equal to. Okay, so not only do you have what the null hypothesis looks like, or what if you choose it to look like, but what you're also going to have is you're going to have the alternative hypothesis and what it should match up to. Okay, and what kind of test you should do as well. All right, that is it for significance test. I'll talk to you later. Bye.